Alright, so in the last video I kind of introduced the concept of a derivative and what it is, and now using the definition of the derivative that I gave you in the previous video, I want to do like a concrete example. So a question would ask, we are given the function f of x equals x squared, and we want to find the slope at x equals, let's say 2, x equals 2. So let's just draw our function. It's a classic parabola. So this is x squared, and say this is 2, and 2 squared is 4. So our coordinate here is 2, 4. And using the definition of a derivative, let's review that. So limit as h approaches 0 of f of x plus h minus f of x all over h. So now we just have to make a second point here. So this would be 2 plus h. And this would be, if you just plug in 2 plus h into our original function, this would be 2 plus h squared. So the coordinate of this is 2 plus h, comma 2 plus h squared. So to make it clear, let's just write down the two coordinates that we have. So 2, 4, and 2 plus h, 2 plus h squared. And simply find the slope of this, so just change in y over change in x. We would get 2 plus h squared minus 4 all over 2 plus h minus 2. So this is what we get. Easy enough, right? And if we expand this, if we FOIL, we get 4 plus 2h plus 2h plus h squared. So let's just simplify this real quick. 4 plus 2 plus 4h plus h squared minus 4. These cancel out. We are left with this. We are left with this. And now let's just complete it by incorporating the limit. We can actually simplify this, we can actually simplify this further. So it becomes 4 plus h. And if we find the limit of this, easy enough, our answer is 4. Yeah, it's as easy as that, really. So you know that for our parabola, f of x equals x squared, the slope at x equals 2, the slope here is 4. So it's really not that difficult. All we have to do is get that formula down and you're good. So what if we wanted to have a more general formula for the slope at any point along the function? So let's just use the same function. F of x equals x squared. So instead of being asked, what is the slope at x equals 2? What if they ask us for a formula that if we plug in a value, will give us the slope at any point? So let us do that. Don't worry, it's not difficult. So we have f of x equals x squared, and we have the definition of a derivative. And this will give us the derivative. And the notation for a derivative would be, one of many notations for a derivative would be f prime of x. This is your derivative. So essentially now we are looking for a derivative, a formula that will give us the slope at any point along the curve. Okay. So f of x plus h, how should we input that here? Well, simply we can just plug x plus h into x. So it becomes x plus h squared. So what I did basically was take x plus h and inputted that for x in my original function. So if, for example, it was x to the power of 9, then we would input x plus h to the power of 9. So yeah, simple. And minus f of x, and for this specific problem, f of x equals x squared. So minus x squared. All over h. So just over h. And once you expand that, we would get x squared plus 2x h plus h squared minus x squared all over h. We cross that out, it cancels each other out, and we are left with 2xh plus h squared all over h. You simplify this further, we are left with this. And now, sorry, my paper is kind of all over the place, but I hope you see what I'm doing. So now we are left with the easy part, find the limit at 2x plus h. We just, as you have learned before, to find the limit, you just plug it in, plug 0 in for h, and our answer is 2x. So this is our derivative. That is your answer. So what does this exactly tell us? Well, you can actually plug in any x value on our parabola. For example, we can plug in 2 like we did before, and our answer would be 4. And that is what we got in the previous problem. The slope at x equals 2 is 4. The slope at x equals 4 is 8. The slope at x equals 0 is 0. So by using this definition, you can find both the instantaneous slope at a point and the formula that will give us the slope at any point on the function. This might seem tedious, and don't worry, in the next coming videos we will have tricks on how to find the derivative of a function quickly without having to use the definition each and every time. Even though you learn the tricks, keep in mind that the AP test will and does require you to know this definition and use it for certain problems. So yeah, I hope this cleared up any confusion. I'm sorry if it caused more confusion, but yeah, thank you and good luck.